Yeah, it works. Okay, so you're up.
All right, hey everybody, thanks for having me and inviting me to talk to you guys today. This is going to be fun. I'm going to have your video up in a window and we'll be able to see what's going on, but for the most part I'll probably be looking at the slides and whatnot. So if you need to get my attention for anything, don't hesitate to speak up. If anybody has any questions as we go along, don't hesitate to ask. And if there's no questions before we get started, we'll just get into it. Let me see. Where's the screen share? All right. You guys seeing that all right?
Yeah.
Okay. Cool. So today we're going to talk a little bit about service-oriented authentication. And, you know, you could call that OAuth for short. And I almost went with this as my title slide just for the comedic effect, but I decided that this was really a better image, or that I liked it because it's kind of symbolic of how apps grow up normally in a lot of ways. You know, they might start with some well-architected, well-thought-out parts, and then you end up with all these weird organic offshoots growing up as, you know, new business needs arise, and as you need to put out the fire of the day, you end up with stuff that, you know, maybe you wouldn't have designed it that way, but that's what you've got, and it all centers around this big ball that is your main application. And I think a lot of gravity develops inside of applications due to login systems. It's real easy to think that, hey, you know, wherever the users can log in is where all of our functionality should live, because that's how we're going to control access to it. And so what this talk is about is ways to break out of that gravitational well and start to architect systems that allow you to still have one single source of your user information, but to silo all your functionality into a series of small applications that all work together. And so a good subtitle for this talk is Stumbling Towards SOA, the story of Cloud HDR. And this is kind of the story of how I managed to get some of this working in my own app. And so some of the things that we're going to talk about is what my goals were. And the reason that's important is because your goals in doing something like this might not be the same as my goals. And so it's important to understand what your goals are so that you can decide if you want to make the same decisions that I did. Because like everything in technology, there's trade-offs here. And, you know, maybe for some people, may not be for others. So I started out with an app that kind of looked like this. It was a big monolithic Rails app. Every single bit of functionality that possibly had anything to do with my app all lived in one big Git repo, was deployed as one application, whether it was stuff that faced the end users, whether it was admin functionality, you know, one-off bits of code to fix data problems, everything, just this one big monolithic application. And I got a chance to rewrite it and ended up with something a little bit more like this. A lot of back-end services that are hosted separately. They live in their own Git repos, and then some Ember apps for front-end that just talk to APIs. And one of the big hurdles that I had in getting this to work was, how do I manage authentication? And what I turned to was OAuth 2. And it's basically an open standard for delegated authorization. So I know that, you know, you might be saying, what if I can't split everything up at once? This is great if you want to do a big massive rewrite, but that's really not a great option for a lot of people. And so, you know, this talk probably wouldn't be very useful if it depended on, hey, you've got to start with a fresh application and just go for broke. So the answer is you can take baby steps to get there. you can start where you are today, even if it means that you've got a big monolithic application. You can plug in OAuth provider functionality into your monolith so that it becomes the single source of truth for all of your user data. And then you can start adding new services that know how to delegate their authentication needs to the monolith. And so this works out great. It lets you start where you are and begin iterating towards something better. So I like to call it the MUXOA. This is the monolith-centric service-oriented architecture. And I'm obviously not affiliated with McDonald's anyway. So here's what we're going to do in the talk, basically, is talk a little bit about service-oriented authentication, how it works in general, and then we're going to look at how to implement it in a Rails app. And first, of course, we're going to start counting at 0 and look at context, goals, and requirements. First, just a bit about me. I'm a coder in Oklahoma City. I'm an organizer of the OKC Ruby group. You can find me on Twitter as Jag the Drummer, and my website is octolabs.com. So Cloud HDR is the app where I've done all of this service-oriented authentication stuff, and it's basically an HDR photo processing automation tool. And basically what it does is, if you've ever tried to take a picture of a particularly bright scene, you end up with something kind of like this, either overexposed or underexposed, and just nothing's quite right. And with HDR, you can combine those to get a much wider range of dynamic range within your images. That's really not important for the purposes of this talk, but just kind of a brief overview of what that is. Some links for some of this stuff. If you go to octolabs.com/soauth, you can find all of these links to demo repos, links to these slides, and also some live demos of this authentication stuff actually working. All right, so first off, goals and requirements. My goals for this were to have small focused apps. I had found places, kind of vertical slices within my application that I could split off into freestanding apps, and that's what I wanted to do. Basically direct users from one mini app to another to accomplish various tasks. I wanted to have single sign-on and single sign-off for all of these apps. I wanted to minimize code duplication between them, especially login code. I didn't want to have to implement login functionality in every single one of these apps. I wanted all of that to delegate out to one central place. And I wanted to be able to support a variety of apps and services. Some of my apps are traditional full-blown Rails applications that have some front end on them, and some are just Rails API apps, but I needed to support authentication to both. So, like I mentioned earlier, I turned to OAuth 2. If you've ever encountered login with Facebook, or login with Twitter, or login with GitHub, that is OAuth 2. And if you understand conceptually what those things do, then you understand conceptually what the goal of this is. So if you're not familiar with OAuth 2, here's a brief overview to it, or a quick review. So assume that you've got a web client that wants to get something at a protected resource in a Rails application. Your Rails app is going to send back a redirect saying, hey, you're not authorized to see this, but go here and they can authorize you. The browser is going to do what it does with redirects and follow that and get to an OAuth 2 provider. At the provider, it's going to send back a redirect. Did I skip a step here? Okay, so once they get, I left out one of the steps here. So when you get to the OAuth provider, at this point it's going to say, hey, you're not logged in yet, and it's going to give you a login screen, ask you to input a username and a password, the standard regular auth stuff. Once you get past that, then it's going to redirect back to the original Rails app. The browser is going to follow that redirect command, and then the Rails app is going to send a post to the provider app that says, hey, somebody just showed up with a token and a secret claiming to be person X. Can you verify that for me? The OAuth provider is going to respond and validate the tokens. Then optionally, the Rails app might ask for some actual user profile information. At that point, the OAuth provider may respond with, name, email address. At this, if you were interacting with Facebook at this point, this is where they would possibly send back some of your friend graph data, interests, hometown, that kind of stuff. And then finally, the Rails app is going to send you the protected content that you asked to see. So again, it's going to redirect you to the protected route. When the browser follows that, then finally the Rails app is going to give you the 200 OK. You're actually getting your protected content. So that's a lot of stuff happening behind the scenes. Did anybody happen to count how many request and response interactions that was? Lots, too many to just come up with. So that's 7, and that was in a very simplified model of this. I left out a few steps that will sometimes happen. So that seems like a real pain to have to implement all of that, but luckily there are some Ruby gems that help make this very easy to do. The first one is a gem called Doorkeeper, and this is basically an OAuth 2 provider gem that you can drop into your Rails app that turns it into a provider. The second is a gem called OmniAuth, which is used in building your own consumer implementation that knows how to talk to the Doorkeeper provider. So what we're going to do is build an OAuth 2 provider, build a tiny gem called SoAuth that knows how to delegate to the provider, and then integrate that gem into a Rails app in order to be able to delegate authentication of that Rails app to the other Rails app. And then you can do that for many Rails apps so that all of your authentication logic lives in one gem but is reused across multiple applications. So real quickly, here's a demo of kind of what this all looks like. So here in this iframe, we're looking at the client. We want to link to some private stuff that the client application needs to protect. When I click that, now I've been linked over to the provider, which is the white background instead of the gray, and the provider is asking me to sign in. So when I sign in here, then I'm redirected back from the provider back over to the client where I'm seeing the super secret stuff that we're protecting here. You can link back and forth, stay logged in as you move back and forth between the client and the provider. And if you're at the provider and sign out and then go back over to the client knows that you're signed out and won't let you at the protected content. So that's the single sign-off portion. Is that fairly clear? Everybody understand more or less what's going on there?
Yep.
Cool. So what we're going to do is then step through the OAuth dance that we just looked at, building or integrating the pieces that we need as we need them. So the first request and response is we want to point at some protected content and then have our Rails app send back a redirect to a provider. So that means we need to do the first bit of the consumer implementation. and that's getting into the OAuth dance. So the first thing that we would do is create a new Rails engine called SoAuth. You can do that using the Rails plugin new command. Using full tells it that you want to have it be a little bit more tightly integrated into the app. If you did, I just blanked out on the alternative to full. That part doesn't really matter that much. So once you've generated your new gem, and then you would open the gem spec and add a couple of dependencies. Add a dependency for the main OmniAuth gem, and then for the OAuth strategy. Once you've done that, in lib OmniAuth strategies, you'd make a file called so.rb, which is going to be the first bit of our client implementation. And so there we just set a few options, set a name, and then set client options that tell it where to find the provider and what the path is where we should authorize, and then the path where we should retrieve a token once authorization has happened. Using Doorkeeper, the values that you see there are just what you would want to use so that you use all of the Doorkeeper defaults. And so then you're going to have an initializer that you would want to be able to generate into a Rails app that's going to hook up this strategy with the OmniAuth gem. That's where you're going to set your application ID and your secret, which allows your hosting consumer to securely talk to the provider. You're going to have just a little bit of content in spec dummy where you can test that you're going to be actually guarding stuff. And then in order to be able to protect content, the most convenient way to do it is to be able to set up a before filter, where you can just say before filter login required, only private, or whatever actions you need to protect. This is very similar to how you do something in Devise. So then if you would update application controller to inherit from the main SoAuth application controller, then you'd automatically have that before filter available to you. So that's where you'd have a login required method, a not authorized method that knows how to redirect into the OAuth dance. So the redirect to line here where it's directing to OAuth/so, that is how you get into the OAuth dance using OmniAuth. The OmniAuth gem is going to set up and deal with that particular route for you. So you just have to redirect to it, and then OmniAuth takes over to actually direct you to the provider and to handle the redirects coming back. So at that point, we're done with step one of the client implementation and are ready to look at the next request and response cycle. So once the consumer has redirected the browser, it's going to follow that, ask to be logged in, and then finally the the hosting or the provider app, needs to redirect back to the consumer. So that's the next step that we need to implement, is how do we handle landing at the provider and then getting away from it once somebody is logged in. So that's the provider implementation. And this is the part that you would do in your current monolithic app if you have one. This is how you would add provider functionality to an existing app. So I'm just kind of assuming that there's already a Rails app here that you're integrating this into. So you just add the doorkeeper-gem into the gem file, bundle install. There's a couple of generators that you need to run for Doorkeeper that will set up a config file for you and add a couple of migrations, and then you need to migrate the database. In the doorkeeper configuration, there's a block that you need to implement called Resource Owner Authenticator. And this is the part where you are integrating with your existing login system on the existing application. If you happen to be using Devise, this is what you would use. The current user or warden.authenticate is the Devise method of doing this. But you basically want to return the current user or redirect to the place where you ask somebody to log in. One of the things that Doorkeeper comes with is OAuth application authorization. And this is like the thing where if you ever click, log in with Facebook, it takes you to a screen that says, hey, application XYZ is asking to log in or is asking if it can use Facebook to log in and would like to have access to the following information. For this kind of purpose where you control both the provider and the consumer, that's really an extra step you need. You really want to make this invisible to users, so you want to get rid of this stuff altogether for this particular use case. So to do that, it's again in the doorkeeper configuration. There's a skip authorization block. Basically, if you return true from this block, it will skip that screen, and if you return, it will not skip that screen. So that allows you to do fancy stuff if you need to for admin users or more privileged users or whatever. Oh, sorry about that. My dog's apparently not happy. All right, so then that's another gem, and that is really the entirety of the doorkeeper integration. It's done everything that we need to do implementation-wise on the provider. So at that point, we're landing at the provider correctly. We're redirecting into the login flow, capturing the user's email and password or whatever we need to authenticate them, actually authenticating them, and then redirecting back. Browsers, of course, follow redirects. At this point, this token exchange is already happening automatically. OmniAuth handles asking token. Doorkeeper handles responding with the token. Through configuration, we've already told OmniAuth to look for actual profile information at me.json. But Doorkeeper doesn't know how to respond with that automatically. This is application-specific information that you need to return. So I guess I'm sorry, one final piece of provider implementation. So in the provider, you need to add a route for OAuth/me to be able to provide that data. And then there you're going to respond with a JSON payload that has whatever data you want to be able to make available in your client applications. And so that's often going to be things like the user's name, so that in the client app you can still address them by name. It might be some sort of centrally stored shared preferences. Anything that lives on that master user record that you want your consumer apps to be able to take advantage of, this is where you would return it in a JSON payload. All right, so at that point, we've returned some data. OmniAuth knows how to... Oh, yeah, so at this point, the last thing we need to do is redirect out of the OAuth flow and get back to our protected resource. So that's the last little bit of the consumer implementation, exiting the OAuth dance. So here's where we configure the retrieval of user information. The raw user info is a method that OmniAuth expects to be there, or is one that it looks for. If it's not there, I don't think it freaks out, but if you implement it you're telling OAuth how to find the user information that you want. Using accesstoken.get is what tells OmniAuth to use the tokens that it's already retrieved to securely retrieve this path from the provider. So then it just retrieves that JSON, parses it, and then we can tell it how to find the UID for the user data. At this point, it's just using the ID that's returned in the JSON. You can also implement an info block that knows how to pull apart the JSON, make that available to your consumers. And then I also like to do an extra block that just returns the raw user info directly, so that if you end up needing to take advantage of additional information in your consumer app, you can do that. So then in the SOAuth, so that we can hook up the OmniAuth callbacks, and this is how OmniAuth handles directing out of the OAuth dance and back into the main application flow. And so then these are also controllers that you would implement inside the OAuth gem so that they're available to any hosting apps. It's basically one small endpoint for creating the session. We're grabbing the OmniAuth information that it makes available in the environment, and then we are finding or creating a user by the ID that we get from that payload. If our local user model wants to store the email, then we update or populate the email, then we save the user, and then we stick that in the session. And then from there, we're directing to omniauth.origin, and that is the URL of whatever directed us into the OAuth dance to begin with. And then there's a failure callback just in case authenticating goes wrong. We can show the user a message that tells them something. A couple of other convenience methods that just make dealing with all of this stuff in your client applications more pleasant. You can implement a current user method that's just going to look up the user that is stored in the session. You can have a signed-in method that just tests if current user is present, and then you can declare those as helpers so that they're available in views and other controllers. An additional helper method would be login required. It's going to call the not authorized method unless we have a current user, and that not authorized method we saw earlier, and it just redirects and gets you into the OAuth dance. So at that point, we've got a fully functional gem that knows how to delegate authentication needs to the provider. The last little bit that we need to do is handle single sign-off. We've got the single sign-on working, but single sign-off takes just a little bit more work. And so on the provider, what we want to do is we're going to use cookies to maintain session state. But we're not actually maintaining the session there. We're just maintaining a marker of whether the provider thinks that there's a valid session or not. This relies on all of your service apps living on the same master domain, but they can be on different subdomains. This just does not work across multiple top-level domains. So in the provider, we have a method called setUserCookie that just sets a cookie that we can look up on both the provider and the client. We've also got a removeUserCookie that deletes that same cookie, and then a convenience method that looks up the domain. This env domain method is mainly useful so that you don't have to change code between your local development environment and production. So then we need to override what happens when Devise starts a new session in the provider. This is assuming that you're using Devise. If you're not using Devise, you do something very similar, but just for whatever particular sign-on solution you happen to be using. And so what we want to do is just tweak what happens when a session is created and destroyed. And Devise makes this super easy to do. We can just extend from the Devise sessions controller and then declare our own create method, and then all of the Devise controllers are set up to really allow really easy extension like this. And so we can just call super and pass it a block. That's going to do the normal session creation that Devise normally does without us having to alter it at all. But then at the end, once the user has actually been, once the session has been set up, it's going to hand us the current user as resource within this block so that we can call set user cookie. And then we're doing the same thing for the destroy method. Let Devise do whatever it always does for destroying a method, but then we need to remove the user cookie. So then for the single sign-off on the consumer side, we're just going to have a couple of additional convenience methods in our application controller. One's a before filter where we check the cookie. And so basically we're just resetting the session unless we find a valid cookie. And a cookie is considered valid if it's there, if it contains a user ID, and if the user ID in that cookie matches the user ID in our current session. And so what this does is it allows the provider, when someone signs out, the provider removes that cookie. So then when you come back and hit the consumer again, this very last line will fail. No, I guess it's actually going to fail soon. This last line, what that does is prevent sign-off, sign-on errors where you sign off as one user and then sign on as a different one and land back at the same consumer. This prevents you from still being treated as a valid user even though you've changed identities. This forces the end. And so then for single sign-off on the consumer side, you just want to add one more route that allows logout there, redirects to, or that route goes to a user sessions controller that's going to destroy the session in our local environment. And then importantly, it's going to redirect to the provider to sign out there and to allow the provider to remove that cookie that other applications may not. So that's really all of the implementation. The only last bit to do is to look at how you use this new gem inside of a Rails app to delegate authentication. So you're going to generate a new Rails app just like you normally would. In the gem file, you're going to point at your OAuth gem. In development, you can just hand it a path and use the local copy that you're using to develop against. For production, I recommend a gem called Vendorize, and what it does is allows you to tell it that you want to use the OAuth gem and have it live within your main app. Another option for this is if you need to keep this gem private, deploy keys, or I'm sorry, not deploy keys, but repository keys at GitHub, or if you can, this probably isn't really going to, this gem isn't going to contain any secrets, and so you probably could just publish this gem and depend on it as a normal gem if you wanted to. So then once you've added it to your gem file, you're going to Rails generate OAuth install. That's going to create a visualizer for you that knows how to set up OmniAuth RB. it would already be configured to look in your environment for both the provider application ID and the provider secret. If you needed to hard code those or look them up from some other place, this would be the place to do it. And then so to get all of this working together, you need to register consumers with the OAuth provider. So Doorkeeper provides a nice admin interface for doing this. So once you had your provider up and running, you go to /OAuth/applications/new, and that's going to give you a chance to give your new consumer application a name and a redirect URI. And this prevents any other applications from being able to basically impersonate your app and take advantage of your user information without you allowing it. Once you create your app, it's going to automatically generate an application ID and a secret for you. Those you'll take note of and then plug into an application like environment config. For local development, this might be a .env file. If you're deploying to Heroku, you set your config variables there. Whatever you need to do to get those into your development or production environment as needed. So then in your consumer, once you've added that gem, you would want to generate a user model that contains whatever of the information that comes back from your provider that you're hoping to take advantage of. In this case, say it's just an email address. Ready to migrate, and then you're going to use the convenience methods that we've already implemented to protect some content that you don't want just everybody getting at. And so, yeah, that's really it. That's the whole overview of kind of how it works and what it does and how you implement it. Again, I hope this shows that you can start where you are, even if it's with a big monolithic application, that you can plug on a OAuth 2 provider and then start with just one service where you split off one tiny little piece of functionality, and then you can evolve the rest of your infrastructure in that manner. So that's all I got. Anybody have any questions?
Question. It's just let's say a fuzzy error in my mind. So when I have one massive Rails app, I have a user model, and logging in's already set up. And if I want to get any information about that user, I can just pull out the user and I have it.
Yeah.
An example, like if I have middle name, now middle name is available to me. So if I use this to, let's say I've got like a subdomained app, and I want it to be like your apps where they're all hooked to the same authentication. So this app is actually a completely separate Rails application.
Yes.
But I want to use this to do the central sign-in. Where's the concept of a user in the second Rails app? The user model is in the first Rails app.
Okay, so you're actually going to have two user models. In your consumer, you're going to generate another user model that may only have a subset of all of the attributes that your main provider has, with the idea being that you have a one-way flow of information user information from your provider to the consumer apps, and so they have to actually mimic and store some duplicate information if they want to be able to take advantage of them. And then that's also in your consumer when you set up the user there. That's how you control, belongs to and has many type of relationships. Where you want to say that the user owns some blog posts or some images or whatever.
Okay.
Does that make sense?
Yeah, it makes sense. And you don't have to worry about going back. But I thought in one of your client code, I saw you taking the ID from that from the OmniAuth server and then doing a user lookup. I don't know how you feel like about the idea of maybe hooking the two database. Like I can have a central database and have my user table, and then have the two Rails apps point, like pull the data from the same thing, but then just use the OmniAuth to carry the ID over, manage the authentication.
Yeah, you could, but at that point, yeah, I'm trying to think what the implications of that are. I mean, you could certainly do that, but it's kind of getting out of the traditional use of OAuth, where you really are trying to separate these things as much as possible.
Yeah, I guess I don't usually. I guess I try to keep the user model free of the joins, I guess. But yeah.
That doesn't happen. That way, if the user didn't exist in the consumer database.
Okay, so it's kind of like in a way you'll have duplicates of the users across all apps, but only when they log into one of them.
You're effectively caching. The provider is still the system.
Okay.
Yeah, I can barely hear anybody other than Darren, but I think that somebody said that you basically have a local cache of the user info at each of your consumers, and that's exactly right.
How do you actually handle refresh tokens in this?
I'm sorry, say again.
How do you handle refresh tokens?
Oh, that is a good question. It kind of depends on app to app. What I generally do is just have my client set the session timeout in my consumers for relatively low, like 24 hours or less, just to prompt doing the dance again often. I think there's probably better ways to handle that, but that's worked for me so far.
So, in this case we were just talking about a minute ago, how does someone's email address get updated in that example?
Okay, so the idea is that all of your user sessions would be, or all of your user data lives in the main app, the monolith, we'll call it, because that was how I was using it, the illustration in the talk. Somebody would navigate to the monolith, update their stuff there, and then the next time that they go through the dance with one of the consumer applications, the me.json payload that comes across is going to have the new email address or their new name or whatever they've changed, and that's going to update the local cache for that particular application. Is that a question?
Yeah, you answered my question, but I guess I didn't see that in the code where it find by ID update attributes. So maybe I just missed it. All right, and then we had a different question.
I was just wondering if there's a way to push it from the consumer. Is if you have separate apps, requiring somebody to go to this monolithic app to do any sort of account maintenance seems a little weird.
So that's one of those things that you're going to want to make a call on an app by app basis, or really more on a data by data basis. If maybe it's one of those things where there's not a big monolithic user preferences screen that covers every nook and cranny of your application. but each vertical slice maintains, settings that are applicable to that tiny domain of the problem. But then your main, hey, I need to change my email address, that happens at your main authentication provider. Does that make sense?
Yes, it does.
How do you handle unauthorized post requests in terms of redirecting it back to?
Sorry, can you say again?
How,
I'm up.
Step up to the mic.
how do you handle unauthorized post requests?
Unauthorized post requests to the
Consumer app. Just in terms of, or just as it pertains to all the redirects, I know that in the example you showed, after all of the authentication, the client was redirected back to the original location of the request that it made.
Yeah, okay, so I may not have talked in as much detail as I should have about how some of those redirects work. When the redirect comes back from the provider, that first one, it includes a token that the consumer app then uses in one of that, like, in-band requests. When you first, here, let me see if I can find the slide for that. I think it's going to be easier to illustrate. So many slides. Okay, so we've gotten this far, let's say, and the user has authenticated with the provider and then is being redirected back to the client. So this redirect happens to a callback URL that is part of the OmniAuth functionality that it provides. It's going to include a code and a state. Those are then used so this is happening in a GET request, and as this GET request is waiting, then the consumer posts that code and that state information over to the provider with the information and the secret key that only this consumer knows. It's only stored here on the consumer. It doesn't actually ever get to the browser. So that's the way of verifying, hey, is this a valid token that's allowed for me? The provider then validates that token and sends back. So this first one is an access token, and then what it sends back is a use token. And then that use token is what's used to actually capture user profile data. Does that make sense?
Yes, it does.
And I guess more importantly, does that answer your question?
I might have been talking about something slightly different, but I think in everything that you just went over, I got the answer to my question.
Okay, cool.
What happens if the user is not allowed to access that private? Okay. Any other questions?
Say again?
Anybody? I'm just asking. Any other questions? All right. I think we're done.
Okay, cool.
Yeah, I really appreciate your time, everybody. Jeremy, thank you for talking to us.
Thanks for having me. This was fun.
Yeah,
Everybody.
Bye.
Bye.